Dear students, good afternoon to all of you. Dear students, good afternoon.
Good afternoon, ma'am. Good afternoon.
Okay, so in today's class, please listen carefully. We are going to deal with a very, very important protocol that is used for communication. Okay, it's one of the very, very commonly used and very interesting communication protocol, which is called SPI bus protocol. Okay, so that is the topic we are going to discuss. Last class, we saw about UART. Can somebody say the full form of UART? What is UART? Can somebody say the full form of UART, ma? Hello? Please respond.
Universal asynchronous receiver or transmitter.
Receiver and transmitter.
And
Okay?
transmitter.
Yeah, good, very good. Universal asynchronous receiver and transmitter. So the word here, the important word I would like to take is asynchronous. Okay, so this is an asynchronous way of communication. Okay, the name itself here, A means asynchronous. So we saw that UART was an asynchronous way of communication. What do you mean by asynchronous way of communication? You have the sender, you have the receiver, right? There is no common clock governing the speed of clock. Okay, there is no common clock governing the speed of transmission. Okay, sender will send it one speed, receiver will receive it in another speed. So in order to avoid that, we saw setting of baud rate. Okay, we saw that we are setting the baud rate. So if this is working at a baud rate of 1200 hertz, then this also we will set it at the same baud rate. Okay, so that we will see the communication between the devices happen at the same speed, bits per second. Baud rate is nothing but bits per second. So we will set the baud rate. So we saw what is the method for setting the baud rate, right? First divided by 12, then divided by 32. Okay, then what is the required baud rate divided by that, and then we saw the steps, right? So that is necessary whenever you go for an asynchronous way of communication. Why do you need to set the baud rate when you go for asynchronous? Because there is no common clock to govern the speed. If it was instead of asynchronous, if it was synchronous method of communication, we need not worry about this baud rate and all that. Okay, because you have your sender, okay, you have your receiver. Both of them are governed by a common clock pulse. So you have a clock pulse, okay, which is the sender will be controlling the clock pulse, okay, and then it is governed. So whatever is the clock speed, same speed the data will be sent and received. So you need not be setting the baud rate. Baud rate setting is not necessary when you go for a synchronous way of communication. Okay, ma. So baud rate setting is not necessary because synchronous is linked with the clock. So now, what is this SPI? Is it synchronous or asynchronous? SPI is a synchronous method of communication. Synchronous. Okay, so naturally you should understand whenever it is synchronous, it doesn't have a baud rate setting. Baud rate setting is not there, but it has a common clock. Okay, common clock to communicate from the sender to the receiver. Is that clear? So the full form of SPI is serial peripheral interface. Okay, serial peripheral interface. Let's see what it is. So this is the introduction about SPI. So SPI, the full form is, it is called serial peripheral interface. Okay, it is used for communication. As the name itself says, the communication is serial communication. Okay, it helps in serial communication. So when I say serial communication, you have your sender, you have your receiver. the bits are sent one by one. Okay, if you send a 1, that 1 will be received here. If you send a 0, the 0 will be received here. So 1 by 1, that is why it is called serial. Okay, and this method is synchronous. That's what I was talking about. It is not asynchronous as in the case of UART. Okay, it is not asynchronous. Here it is synchronous. So whenever the word synchronous comes, please remember there is a common clock. Okay, and it works using the serial communication interface. Your 8051 has got serial communication interface, right? So it is working using that interface. Another important point is it is used only for short distance communication. When you want to communicate between your computer and a printer, computer and a short distance, okay, not for connecting between areas and all that. This is not, that is one of the limitation of SPI. SPI cannot be used for long distance communication. It can be only used for short distance communication. Dear students, are you following me?
Yes, ma'am.
This protocol was developed by the company Motorola in the year 1980. Okay, that is why we are able to successfully use it in 8051. Okay, next. This is another advantage of SPI is it is full duplex. You remember last class I told you half duplex, okay, full duplex and all that. So this is full duplex. So which means sender can send at the same time it can also receive. Okay, so this is a full duplex mode of transmission that can happen. Okay, ma. And here there is a very special architecture in SPI which is called master-slave architecture. If you don't understand right now at this point, leave it at the later stage. When I explain the whole thing, you will understand. Just remember the name of the architecture in SPI is called master-slave. So I think from the name itself, somehow you would have guessed there will be one master and there will be some slaves. Okay, so that is the architecture on which SPI functions. And it is a must that SPI should have only a single master. Okay, so master slave, see, master slave can be like many masters, many slaves. No, in SPI there should be only one master. Okay, and you can have any number of slaves. Slaves can be many, but master should be only one. Okay, you can have slave 1, slave 2, slave 3 and so on. That is not a problem, but you should be having only one master. Okay, that is the rule of interface of SPI. The master should initiate all the process. Okay, should initiate the clock, should initiate the data, everything should be done by the master. That's why it's called as master. Okay, and you have also, the master also has the ability to select which slave at that particular time that it has to communicate. Suppose there are 4 slaves. The master can very well select one of the slave and then communicate with that slave alone. So this possibility is available with the master. If it doesn't want to communicate with slave 2, it can just disconnect, go to slave 4 and then start sending information to slave 4. So at any point of time, master has all rights to select and deselect a particular slave. Is this clear, ma? Any doubts?
No, ma'am.
Shall I move on?
Yes, ma'am.
Okay. Next is, there are some problems with UART. Already in the last class we discussed about UART. One is, main problem is it is asynchronous, which means 2 devices when you want to connect or communicate, both of them will be having a different clock. So you will have to set the baud rate. So setting baud rate itself, is a separate procedure. It takes some time and for setting the baud rate and all that. So that has to be done. It is a must. Another biggest advantage of UART is the overload. You remember I was talking about overload. What do you mean by overload is, see, when you want to transmit an 8-bit data, okay, from the sender to receiver, can you send only the 8-bit data or should anything be attached to it? In UART, can you send only the 8-bit data or you should attach something to it? Come on, somebody please answer me. Should you attach something to it? If so, what should you attach? Hello? In UART, you're sending the data. Is data sent alone or something is attached and then sent? If so, what is attached? Dear students, please open your mouth and answer me. The answer starts with yes.
Ma'am, 2 bits are attached on
What are the 2 bits?
start and end.
Very good. Start bit and stop bit, right? 2 bits are attached. So for sending every 8-bit data, we need to actually send it as a 10-bit data. Okay. So the overload we saw was 25% overload. Okay. Overhead was 25%. So what is this 25% overhead is? See, the data is not continuously sent. If I have to send 2 8-bit data, okay, suppose let's take an example. I want to send 2 8-bit data. Okay, 2 data, both are 8-bit. I cannot continuously send when I use UART because this data will be attached with start and stop. This data will be attached with another start and stop. If I have to send another third data, again start and stop. So what happens is attaching start and stop is one process, and at the receiver end, removing the start and stop is another process. Are you getting my the idea of that I'm saying? Attaching start bit and stop bit is an extra process, and at the receiver side, removing the start and stop bit and sending only the data is another process. So all this takes slightly a longer time and more complication. That is the reason why UART is less preferred than SPI. Have you understood the logic?
Yes.
Yes. And another, yeah, that's what we are talking about, the overhead. Okay, and extra bits have to be attached. Complex hardware, because we need hardware to attach the bits. We need hardware to remove the bits. Okay, all that. So that is all having some extra work to be done. Okay, and more importantly, both the sender and the receiver side are not operating at the same speed. Okay, so suppose there is any loss of data, then there is more possibility that there would be some loss of data or erroneous data being sent. Okay, so that is one of the major disadvantages of synchronous data transfer using UART. Okay, so that is why synchronous instead of asynchronous, synchronous is more preferable. Why synchronous is more preferable? Because this has got a clock. Okay, and this clock can be, completely synchronized between the sender and the receiver. So this clock is present in synchronous. That is why it is more advantageous than the asynchronous. Okay, ma. Now coming to the SPI protocol details. Let's go into that one by one. Okay, the SPI protocol, as I told you, it works on a master-slave relationship. Okay, it works on a master-slave relationship, and the side that generates the clock is known as the master. Okay, the side that generates the clock, whichever device generates the clock. Suppose I have a computer. Okay, I have a computer and I have another display device. Okay, let's say this is a display device and this is my computer. Okay, now since computer is generating the clock to the display device, this is known as the master and this is known as the slave. Okay, suppose I have 2 computers. This is one computer connected with another computer for some other interfacing. This is also computer. Now this also has a clock. This also has a clock. But whichever is generating the clock for that communication. Okay, suppose if this computer is generating a clock for the communication, then this will be acting as master and this will act as slave. So the direction will be this side. The arrow will be facing this side. Got it? So whichever device is at present generating the clock, that device is known as master or slave? Master or slave?
Master.
Master. And the other side is called the slave automatically. SPI should have how many masters? Can it have any number of masters?
No, ma'am.
There should be only one master What about the number of slaves, ma? Is there a limitation that there should be only one slave?
Any number of slaves.
Any number of slaves. Okay. And this is like mostly a master will be a computer, it will be a microcontroller, okay, it will be a processor, something like that. They will be the masters because they have the clock. And usually slaves will be like some sensors, some display device, some micro memory chip. Okay, all that will be an example of slaves. Okay, so mostly that processors and controls will be a master, and something that obeys the instructions from the master, like a sensor, a display device, a communication device, a memory chip can be a slave. Okay, ma? So let's deeply go into the logic of master slave of SPI. So here if you see, let me just push this diagram so that. Okay, then. Okay. Now coming to the master slave, this is how the SPI communication actually happens. Please remember, this is very, very important. SPI has got 4 logic signals. Okay, SPI has got 4 logic signals. What are the 4 signals? Let's go one by one. The first signal is called serial clock. Okay, serial clock, S clock. Okay, that is the first signal. This signal has to be generated by the master, because only then it is called a master. Whoever generates the clock is called the master. So, master also will have a serial clock, slave also will have a serial clock. The only difference is one who generates the clock becomes the master, one who receives the clock becomes the slave. Clear, ma?
Yes, ma'am.
That is the first logic signal. The second logic signal is called MOSI. Only the name is difficult, very simple. Master output, slave input. So from the name itself, it's clear. The master will be giving the output bit through this channel. Slave will be receiving it. So the direction goes like this, from the master to the slave. Okay. There is the third signal, opposite of it. Master input, slave output. So which means what? I told you this is a full duplex communication. So communication can happen from master to slave, also from slave to master. So the second signal is opposite. The slave is giving the output, whereas the master is receiving it as an input. So this is sending, this is receiving signal. Clear, ma? And the fourth important logic signal is called SS. Please remember these names. They are all very important for your test. Okay, this is called SS. SS means slave select. As I told you, your SPI can have a single master connected with multiple slaves. Slave 1, slave 2, slave 3, slave 4. At a time, you can communicate only with one slave. Communication can happen only with one slave. So you should be able to select that particular slave. For that only we are using this SS, slave select. The other name is chip select. That is why it is written CS. Chip select or slave select. SCLECT. Slave select or chip select. Clear, ma? So can somebody say what are the 4 logic signals of SPI? What are the 4 logic signals of SPI? One is the clock. Second,
Master output, slave input.
very good. Master output, slave input. Next,
Master input, slave output.
very good. The other way, master input, slave output, and the last one is
Slave select.
slave selecting the slave. Fantastic. Okay, so that is the 4 logic signals. Now, the details about each signal is given here. Okay, just go through this. I have already explained to you, so I am just skipping this. It has to be initiated by the clock. All this we have repeated again. Okay, now in case, see, there are 2 ways of connecting your slave. Okay, there are 2 ways of connecting your slave from the master. One is you have your master. In your master itself, how many slave select pins are here? Just look at this diagram and tell me how many slave select pins are there. SS pins, how many are there? SS1, SS2, SS3. Can you see 3 pins? Can you see 3 pins here? Hello, ma?
Yes, ma'am.
Yes, ma'am.
So which means what? At a time, how many slaves you can connect? Through SS1, you are connecting one slave. Through SS2, you are connecting the second slave. Through SS3, you are connecting the third slave. So at a time, you can connect 3 slaves. This is one way of connecting. Okay, this maybe your computers can have this. Okay, your normal PC or your computer can have this way of SPI communication. Not all SPIs will have multiple SS pins. Some SPIs will have only a single SS pin. Can you see the difference between this and this? Here there are multiple SS pins. Here there is a single SS pin. Okay. In case you have a single SS pin, then also you can connect multiple slaves. But how do you connect this? You connect it using daisy chain method. Okay, you connect it using daisy chain method, which means first this slave will be connected. If that is not okay, then you go for the second. That is not okay, then you go for the third. Okay, so that is called daisy chain. So single line is connected to this yellow line. Single yellow line is connected to all the 3 slaves. At a time, you can choose one slave and then function that. Okay, so if you have a single SS line, you use daisy chain. If you have multiple SS lines, that many number of slaves can be connected. Okay, yeah, and I think almost that's it. So we'll see how actually the process happens. First step, the master should output the clock signal. Okay, the first step, master should give the clock signal. So clock signal from the master will reach the slave. See, the arrow goes this way. The arrow goes from the master to the slave. Okay, please remember the arrow here goes from the master to the slave. So that is the first step. Okay, the second step, master should select the slave, whichever slave, slave 1, slave 2, slave 3, like that, the slave has to be selected. So second step is SS. First step is clock, okay, serial clock. The second step is SS. The third step, if master has to transmit the data has to be transmitted. If master needs to transmit the data has to be transmitted. Okay, and when you transmit the data, you please remember MSB will have to be sent out first. In case of UART, we saw LSB was sent out first. But in case of SPI, MSB will have to be sent out first. Okay, so MSB first. This is very, very important in SPI. So if master has to send out something, master output, slave input line will be active. So it will start sending out the data. No start bit, no stop bit. So data will be sent continuously. 1, 2, 3, 4, 5, 6, 7, 8. 8-bit data. No start, no stop. Okay, so all that comes is only data, no extra bits. Got it? And which is sent out first? MSB is sent out first. Okay, in case the slave wants to communicate back, then the next step is slave will be sending out data. So this is the master input, slave output line. Here, in this case, your LSB is sent out first. Please remember this. This is very, very important. Whenever master sends the data out, master output, slave input line, your MSB is sent first. In case of master input, slave output line, your LSB is sent first. This is very, very important. Okay, ma? So that is the 4 steps. First, initiate the clock. Second, select the slave. Third, if you have to send data, send it, but send with MSB as first. If you want to receive data, receive it with LSB first. This is clear to all of you? Clear, ma?
Yes, ma'am.
Next is, how does the sending and receiving data happen? See here, 8-bit data is sent out, right? 1, 2, 3, 4, 5, 6, 7, 8. Here also 8-bit data is sent from the slave to the master. Here from the master to the slave. So what happens? How exactly the sending of data and receiving of data happens is, when you zoom into the master and when you zoom into the slave, you will see that actually this MOSI and MISO are connected in a ring topology. Okay, virtual ring. It doesn't actually be a ring, but it looks like a ring. Ring topology. Why you call it as ring topology? Here you have 8-bit register. Here you have another 8-bit register. So this is like rotating the bits. One by one, this bit will be sent here. This bit will be sent here. This bit will go here. This bit will go here. So this is like, you're rotating. So this last bit. Sorry. See here, this last bit, 7th bit of master will go and sit in the 0th bit of slave. Okay, so at that time, again, the 6th bit will move to the 7th bit. The 5th bit will move to the 6th bit. Okay, the 4th bit will move to 5th bit. So it is one by one, right? So that will go there. Then again, this will keep moving here. Okay, then when slave wants to communicate, this way it will start communicating. Okay, so this, you imagine that there is a ring topology between the MOSI and MISO. Between these two signals, there are two registers which act in the form of ring topology. So these two registers are called shift registers. Okay, ma? Which has a in 8051, the shift register capacity is 8-bit. Higher processors and controllers, the shift register size may vary. In 8051, it's only 8-bit. Got it? That is why 7th bit, is it MSB or LSB? 7th bit is
LSB.
7th bit, 0th bit and 7th bit, which is
Oh, sorry, MSB.
MSB, right? So MSB. So when you send the data from master to slave, which is sent out first?
MSB, ma'am.
MSB is sent. You got it? So that is that you should remember. Okay, ma? Yeah. And I have given the advantages already. We discussed advantages is full duplex is one of the main advantages. Fast throughput. Okay, the communication is comparatively faster than next class. We will be discussing what is this I2C bus. So even faster than I2C bus. Okay, and it is not limited. It is completely synchronized by a clock, so you need not worry about data loss and all that. And not limited actually to 8-bit, because 8051 has got a capacity of 8-bit registers, it is limited. Otherwise, depending on the size of the registers, communication can happen at any size. Okay, ma? And here, very importantly, you need not go for a baud rate setting and all that. Okay, not necessary, because they're controlled by a clock. And here you can have any number of slaves, but only one master. Okay, limitations is it requires more pin, okay, IC package, and there is no hardware flow controlled by the slave. Only master can control the flow. Slave cannot control. Okay, only master has all the rights to do. Slave, because it is working on a master-slave architecture, master has all flexibility, but slave has got a limited flexibility. Okay, ma? And even acknowledgement is missing here in this method. In the next one, I2C will be, excuse me, will be having an acknowledgement signal. Here, acknowledge. What do you mean by acknowledgement? When you send any data, you should be receiving an acknowledgement saying that I have received the data. That is missing in SPI. Okay, and SPI supports only one master. You cannot have more than one master. And last disadvantage is there is no error checking available in whether the data sent and received is same. That kind of a mechanism is not possible in SPI. Okay, ma? That is a limitation. What are the applications of SPI? Varied applications. Okay, it has got variety of applications. Number one, very easily you can connect sensors. It can be any type of sensors, temperature sensor, pressure sensor, ADC, DAC, touchscreen, video game controller, anything can be connected very, very easily using SPI. Second, you can connect all types of control devices, okay, like potentiometers, digital to analog, audio codec and all that. You can also use it to connect memory devices like flash memory and EEPROM can be easily connected with your 8051. And also real-time clock. Okay, when you're going for any real-time application, okay, you can connect a real-time clock. LCDs can be connected. Okay, SD cards, memory cards can be connected. So all these are all actually being used right now. Okay, using SPI. So these are all the applications of SPI. Got it, Ma?
Yes, ma'am.
Yeah. So that is about SPI. I hope this is very simple, right? So SPI is, when I say SPI, remember it's full duplex. It is synchronous communication. It uses a master-slave architecture, which has got one master and can have any number of slaves. It has, what are the 4 logic signals of SPI? It has got a serial clock, master input, serial output, master output, serial input, okay, and then slave select or chip select. So these are the 4 logic signals of SPI, okay, and it is like, it is a very easy method of communication, okay, with no extra overhead bits added, no start bit, no stop bit, nothing. Just directly the data has to be sent. But please remember, when you send the data out, from master to slave, when you send, MSB should be sent out first. From slave to master, when you send, LSB should be sent out first. Okay, ma? That alone is very, very important. And then you can have any number of slaves, but master should be only one. If there are many slave select pins, you can connect that many slaves. But if there is only one slave select pin, you can use daisy chain method to connect more number of slaves. Okay, then we saw advantages, disadvantages, and applications of SPI. Clear?
Yes, ma'am.
Any doubts? Any clarification needed? So we have completed RS-232. We have completed synchronous and asynchronous communication basics. We have completed interfacing of peripheral devices, timers and counters we have completed. ADC and DAC we have completed in the lab. Some more data is remaining. I will be telling you in one class. And we have I2C and introduction to interfacing of Bluetooth. Okay, so this is the syllabus for your test 3. The test 3 syllabus starts from ADC, DAC, timers and counters, interfacing of peripheral memory devices, synchronous and asynchronous, RS-232, SPI, I2C, introduction and interfacing of Bluetooth. Okay, ma? So it starts at 28 and it goes to 37. That is the syllabus for test 3. More, I have to complete I2C and I have to tell you about a little bit about, already you know about ADC, DAC we have done in the lab, but still I will tell you a little more about ADC and DAC. Okay, ma? Please answer your attendance. Jalati Preetham,
Present, ma'am.
Oliver,
Present, ma'am.
Jolin,
Present, ma'am.
Samraj,
Present, ma'am.
Angelin,
Present, ma'am.
Jal,
Yes, ma'am.
Joel Sam,
Present, ma'am.
Steve Abraham,
Present, ma'am.
Aditya,
Present,
Ma'am,
ma'am.
present.
okay, Bevin,
Present, ma'am.
Romia,
Present, ma'am.
Sam,
Present, ma'am.
Rimina,
Present, ma'am.
Alex,
Present, ma'am.
Jobin,
Present, ma'am.
Catherine,
Present, ma'am.
Shamima,
Present, ma'am.
Bharat,
Present, ma'am.
Ashish Kumar, Ashish Kumar, Richard,
Yes, ma'am.
Atul,
Yes, ma'am.
Nikhil,
Present, ma'am.
Abel,
Present, ma'am.
Tabas,
Present, ma'am.
Sam Jonathan,
Present, ma'am.
Vigneshwar,
Present, ma'am.
Tin,
Present, ma'am.
Nuntuk,
Yes, ma'am.
Jessica,
Present, ma'am.
Itisha,
Present, ma'am.
Benvin,
Present, ma'am.
Christina,
Present, ma'am.
Corina,
Yes, ma'am.
Ayuri,
Yes, ma'am.
Patrick,
Yes, ma'am.
Rona,
Present, ma'am.
Tiba,
Present, ma'am.
Anna Thomas,
Present, ma'am.
Anna Daniel,
Yes, ma'am.
Nagabhavani, Nagabhavani, Sharan Sudhir,
Present, ma'am.
Ma'am, 100 present, ma'am.
Rajashekar,
Present, ma'am.
Grace Angela,
Present, ma'am.
Swati,
Present, ma'am.
Santosh,
Present, ma'am. Present, ma'am. Present, ma'am.
Priyanka, Christo Singh,
Present, ma'am.
Genuine, Davi,
Present, ma'am.
Jackson Samuel,
Present, ma'am.
Christopher Paul,
Present, ma'am.
Abhishek,
Present, ma'am.
Joseph Raj,
Present, ma'am.
Lesson,
Present, ma'am.
Joel Sanjeev,
Present, ma'am.
Prasanna Kumar,
Present, ma'am.
Pavani,
Present, ma'am.
Vaumik,
Present, ma'am.
Dhanush Ram,
Present, ma'am.
Manashwini,
Present, ma'am.
Nitin Prince,
Present, ma'am.
Solomon Raj,
Yes, ma'am.
Etshia,
Present, ma'am.
Gaurav, Etshia,
Present, ma'am.
Gaurav is there,
Present, ma'am.
Present, ma'am.
Nandini,
Present, ma'am.
Livingston,
Yes, ma'am.
Anush,
Yes, ma'am.
Kevin,
Present, ma'am.
Tripula Devi,
Present, ma'am.
Narmada Reddy,
Present, ma'am.
Lakshman,
Present, ma'am.
Sharat Prabhu.
Present, ma'am.
Okay, ma. Thank you. You can leave.
Ma'am, 100 present, ma'am.
No, ma. You didn't see. Others can leave, ma. Okay, ma. Thank you.